Friends, welcome to ML with AP. This is the video 5 and today we are going to discuss about functions, lambdas and what they are and how do we use it. But a slight recap over there. In the last video, we discussed about the control flow. So we discussed about the if, else, elif statements. We also discussed about the for while loop and how we can make use of the break, continue and pass. Okay, so if you have not watched my previous videos, I highly recommend you to go ahead and watch it. That will give you a more solid foundational understanding of what is going to come. Okay, with that being said, let's go and talk about functions and lambdas. Okay, so far our scripts have been very simple, single use code block, whether it's a while, for, loop, all those things were simple. Now one way to organize our Python code is using functions. Now what is the need of functions? And if you have any background in any of the programming language, by now you would have guessed, right? Functions serve two purposes, right? The major function which function serves is reusable. Okay, so it's a reusable piece of code. If you have to call a particular piece of code multiple times, it's a good idea to make it a function and keep calling it. It also helps in readability. Okay, so let's say how it helps. If you have to that same piece of code, if you put multiple times in your code, in your program, it will become highly unreadable. It will become longer also, and the readability will also be lost. So two primary reasons why functions are used are essentially because of reusability and readability. Okay, now today we are going to cover, and this is done in two ways. One is functions, the second is lambda. Lambda is nothing but a shorter version or a micro version of functions which are anonymous, right? We'll just dig little deeper into towards the end of this section, but let's put our main focus on functions and how we do that. Okay, so let's jump to our Jupyter notebook over here. Okay, yeah, so the way we define a function is using the def keyword. Okay, and even before that, let's intuitively understand what a function is. So let's start with a built-in function. What better than is print statement? Print is a built-in functions, right? So I'm printing ABC, it prints, right? So it accepts an argument. This is a function which is an inbuilt Python function. It accepts an argument which is ABC in this particular case, and it gives an output which is ABC. Okay, so it prints. Okay, now these this is function, this is argument. This argument can also be of two types. Okay, now what are those two types of arguments? And we'll talk about them just in a while. The arguments are positional argument and keyword arguments. Okay, positional and keyword argument, and we are going to deal both of them separately. But let's understand and build intuition more on what functions is. Now if you notice, in print we can pass a series of number also, and it prints the whole thing. It doesn't limit how many numbers we are passing, right? So somewhere it understands that, hey, no matter how many arguments you are passing, I'm going to print all of them. Okay, now let's see. And friends, I have already discussed that for every function, you always get, with a shift tab over here, a doc string, right? The help kind of thing. If you expand the help for print, what it will say? It will say value colon 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 colon. That means it can accept any number of values, right? But it does have some other arguments which it can accept, not normally used, but it does have. So it has something called separator. Let's see what separator is. Separator is a string inserted between values, default as space. So if you do not specify any value, which over here, let me minimize this. If we have not specified anything, the default is a space, right? Let's see and define something over here. 1, 2, 3. Okay, and this time what I'm doing is I'm making use of this keyword argument also, which is, and I will pass it as a single quote, and I will try to pass a star inside this. Okay, now let's see what is happening. So my separator, which was default was a space, now change it to star star asterisk asterisk, right? And it is printing 1 2 3, but in between it is printing asterisks also. So these are the two type of arguments which are, one is positional, which are these arguments. The second, which is called by a keyword, in this particular case separator. Okay, so this is the basic difference between a positional and a keyword argument. There are other differences also which we'll deal. Okay, now let's see one more a small nuance of it is keyword argument should always be at the end. So you cannot have that positional argument after keyword argument. Okay, let's see what it means. So if I have to specify 1 2 3, let me copy this thing. Okay, if I do this and at the end I'm sending one more positional argument 4, see what error it is showing. Positional arguments follows keyword argument. So this was my keyword argument. Python expects you to send keyword arguments only at the end. When all the positional arguments are done, you can send a keyword argument. The order, if you have to send multiple keyword arguments, the order is not important. Okay, and we'll see just in a while that why it is so. It is very intuitive and very easy to understand also. Okay, so we have seen. So one key concept is that positional argument should before your keyword arguments. Okay, now how do we define functions? Okay, let's define a function, and the best thing is to do with an example. Okay, so in this I am going to define a function which is called Fibonacci. Okay, so Fibonacci is a series of numbers, is a number series. What it does is that previous two entries gets added and forms the next number in the sequence. So my, let's say my sequence is going like I starting with 0 and 1. I'm starting with, okay, let me just do it over here. It's not important for this logic, but in general, if you want to understand what a Fibonacci series is, it's a mathematical series. So I will say that, okay, if my first number is 0 and the second number is 1, my third number will be my summation of 0 and 1, the first previous two numbers, so 0 and 1, and so it becomes 1. Now, what will be my third number, multiply the next subsequent number? My summation of 1 and 2, which is 1 and 1. Now, what will be my next number? My summation of previous two number, my sum of previous two number, which is 1 and 2, which will become 3. Subsequently, next will be 3 plus 2, 5. Subsequently, next will be 5 plus 3, 8. After that, 8 plus 5, 13. After that, 13 plus 8, 21. Sorry. Now you got the idea that how Fibonacci numbers are built. I'm just taking this for an example. It is not important. Okay, that you need to know what Fibonacci is. Okay, but for this particular example, it will become much more easier if I take that case. Okay, now what? Let me write the code first and then. Okay, and let me append here. I will append, and then finally I'm going to return L. Okay, so let's try to understand what this code is doing. Again, absolutely not necessary that what you need to understand Fibonacci, but let's see what this code is doing. So how a function is defined? It with a def keyword. Okay, so if I am doing it like this, Python interpreter note that I am defining a function. Okay, and this has a parameter which it accepts. It accepts a parameter which is called n. It's a positional parameter, right? Because I'm not specifying any keyword, it's a positional parameter. Okay, I'm specifying some n over here. Now within this code block of this function, I'm defining an empty list, initializing an empty list which is L. Okay. Now I'm initializing two int variables also, a and b. This is the way in Python you can initialize. So a gets assigned 0, b gets assigned 1. And it's very easy, compact way. Again, for a lot of things in Python is very compact and easy to intuitive to understand. This is one of those things. So this is unpacking. 0 gets assigned to 1. a be assigned to 1. Okay, now this while loop, which by now we already know what while loop is. So when I'm doing y len l, len is the function of l, so it will give you the length of l. Okay, while len l is less than n, n is a number which is passed over here as a parameter, as an argument. What it is doing? It is assigning b into a, and what it is doing? It is assigning a plus b into b. Now, if you guys notice over here, what it is doing is it is assigning my every number is made of the last two numbers, right? So what it is doing? It is assigning the previous number as 1, okay, into a plus b, the last two numbers, right? So it is building the next number b always as the addition of a plus b, the last two numbers, right? It is doing that. And again, if you are not able to get this, just spend a little bit time and it should be pretty easy to understand. Even if you are not understanding, don't worry. The key concept of here is that how functions are defined, and that we should be thorough about. Now I'm appending in the list the number a, and then I'm returning l over here. While when I'm returning, when this particular while statement is executed, all it is doing is when we are calling it, let's say I'm calling it, I'll just, so that I don't do a spelling mistake, I will copy it, and I'm passing as a variable argument 10. When I'm passing this argument 10, let me execute this also. And when I am doing this Fibonacci, I'm doing a call on Fibonacci function, and I'm passing an argument 10. This 10 goes into n. Okay, then this particular function gets executed. Now L empty string, a is 0 and 1, a is 0 and 1. Len of L, now len of L is 0 itself. So this statement is true. This is less than 10, right? Because n is 10, the capital N is 10. This will get assigned and we'll compose a new number a, and we are going to put it into our list. Okay, and subsequently we'll go ahead and build the list. Okay, now let's assign this. Okay, okay, so it is saying that built-in function or method object is not subscriptable. I think I did a mistake over here. What I will do is, this is not subscriptable. I should not be using a square bracket but in a smaller parenthesis. This is a function call, right? Len function call. Okay, now let me execute this, and it gives you the first 10 Fibonacci series number. So again, nothing important to know Fibonacci, but if you notice that 1 1 2 and 2 plus 1 3 and 3 plus 2 5 and 5 plus 3 8, but all you should take from this, even if you do not understand Fibonacci, is that I'm passing an argument. That argument is going over there, and based on certain condition which is written within this function, it is returning me a list, and this is the list, right? Again, the core concept over here is that how the function is written with the def keyword, and inside that keyword you put the code block with the logic. Whatever logic you write, when I'm calling the function, I'm calling with an argument, positional argument in this case. This argument goes over here, it executes the code, and the return is passed on. Now the return in this particular case is a list, and what we are seeing is the number list over here. That's all you should understand for now. Okay. Okay. Now one thing is very interesting over here is that if you are familiar with not dynamically typed but a strongly typed language like C, you'll immediately notice that there is no type information associated with the function input or output. We are not explicitly calling this is int, this is float, or nothing like that. Okay. So Python functions can return any Python object, simple or compound. In this particular case, what is it returning? It is returning a list, which is a compound data type. Okay, not it can return a number also, integer, float. It can return another object, any object it can return. Okay, it can return multiple return values also. Okay, so let's say if you have to return something you can return the last value also. for that matter this 55, right? If you have to return the last value also, if you are returning L and A, you can return both of those things also. Okay, now how you can do, let's say, okay, so I'm at the end, my last value will be A. Okay, I'm returning. Okay, so if you see, notice over here, my first list is getting returned, which is L, and I'm also returning the last value, which was the last A, right, over here, which was 55, right? I'm returning. So you can return multiple values also. Okay, simple. Okay, now let's see, there is another, till now we have seen two concepts of positional, when it comes to arguments, we have seen positional and keyword arguments. Now there are default argument values also. So what happens is, often when we are defining a function, sometime we do not want always to pass a value as an argument to the function, but sometimes if we do not pass, then the function should automatically take a default value, right? Okay, let's see it with an example over here. Okay, now the example, let me copy that. Let me remove this and copy the same code. Okay, so that it will become easier. And instead of n, what I'm going to do is, I'm passing, not initializing my a and b, but I'm passing my a and b also. So what it will do is, it will start my Fibonacci series from that particular number, from those two numbers. Okay, so let's say a is equal to 0, comma b is equal to 1. Okay, so 0 and 1 were the initialized ones, right? Now let me see that what it is going to do. Okay, I ran that function. Now let me call again. Okay, what it is doing, it is printing me the same value over here, right? What it was there earlier. So the same list is being returned. Now instead of initializing, I'm passing that as an argument. So a and b are my argument. But what type of argument? If you notice over here, it has a default value also attached to it. So I have now two options. One, either I can pass or I can choose not to pass. In this particular case, I'm not passing it, right? But let's say what happens if I have to pass. So my first argument, it is saying I have to pass A. So I pass A as 1. And instead of passing B as 1, let me pass 2. Okay, it gave me a different Fibonacci series because my initial numbers 0 and A and B have changed. Okay, so it gave me a different list over here. Okay, now let's see what happens is if we do something like this. Okay, A is equal to 0 and B is equal to, my default was 1, remember, I'm passing, but I'm superseding that and passing built as 2. Okay, it is giving me 0 and 2. So my default value was 1. If I didn't pass, it took 1, returned this list. If I'm explicitly saying that no, my A should be 0, B should be 2, it is still taking that. It is superseding the default values and returning me a list. Okay. Now, friends, I've already told that positional arguments cannot be after the keyword argument. Let's see over here that what we are doing. Okay. Let's try to do a few funny things. Okay. So what I will do is, I will try to write over here is, let me define my first argument I should be defining as A, the next argument is B. Okay, but what I will do is I will change it. Okay, I'm defining my, okay, yeah, so I'm passing A as 2. Okay, and then there is a number over here also. Okay, now what is happening over here? It was expecting that my second argument will be A, and my third argument also I'm passing it as A. So it is saying that got multiple values for argument A, right? So this anyway it is treated as A, this also it is getting as A, and it is throwing an exception. So we have to be mindful of that also. Okay. Now let's talk about, now I hope guys by now the default arguments and the positional arguments and keywords argument are a little bit clear. Okay, but anyway, let's see a few more examples to make it more clear. Okay, we'll see the examples of keyword arguments. I will do and mark down keyword. Again, I will see my running example of Fibonacci. Okay, and this time I will remove it from the default. Okay, I'll keep it positional. Okay, now if I'm keeping it positional, let me swap the positions this time. Okay, I'll define my function. No problem. It didn't give any error. That means it was okay. Okay, now let me copy this. Okay, now if I pass what will happen? Think for a moment what will happen. It will give me a value knowing that my A and B have now become keyword argument. I'm passing A and B using keyword. It is expecting three things. One is the positional argument and I'm passing as 10. The second is expecting B and A. Now B I'm supplying as a keyword argument. B is equal to 2. And A I'm supplying as a keyword argument. A is equal to 0. So my Python function is able to understand that B is 2 and A is 0, and that's why this is giving the same number what it was giving over here, if you notice, right? Okay, clear? Now let's try to play around with it. Okay, now let's see what will happen if I do something like, let me copy this thing. Okay, if I do B over here and A over here, okay, it's still working, right? Okay, just to ensure that we are getting the same repeatable result, let me put the value. Okay, it is giving the same repeatable result. So this order of the keyword argument doesn't matter. Why it doesn't matter? Because the Python understand that I'm passing B and I'm passing A over here, because I'm explicitly saying that, hey, my argument B is 2, argument A is 0, and these are my keyword arguments. As long as I'm putting them behind my positional arguments, I'm fine. But if I swap that, it will create a problem. Okay, now let's see the third case. Okay, now in this particular case, what I will do is I will give it 0 and B is equal to 2. Now my B is only the positional keyword argument. My A is positional over here, right? In the second position, it was expecting a B. Here, I'm supplying, it will treat this as B and this also as B, and you can expect what it is going to throw. It will go to throw an error because it is expecting now this positional argument as B, and it is getting one more B. It is saying that no, you are supplying too many B's. I'm not taking it. Okay, so it will throw an exception. Now let's see one more case over here. Okay. Okay, let's put it's 2 and A is equal to 0. Okay, this is fine because it will say that my B is 2, which is a positional argument now. My A is a keyword argument, which I am passing as 0. And okay, I missed a comma over here. And it will run and it will give you the same output. Okay, so the important thing is few key concepts. One is the default arguments, what we have seen already. So the default arguments is in the function definition. If you see the default arguments over here, okay, yeah, is in the function definition itself. The parameters are passed. Okay, if you're not passing, it will take it as a default value. That was one concept. Second concept is positional argument, like N, B, A, these are positional arguments, right? If we are specifying something with the keyword, it becomes a keyword argument. In the case of a keyword argument, you have to specify it and specify it towards the end. That's all. The order doesn't matter, we have seen. So if you can A here and B here, it still understands that I'm passing A and B both. You have to pass all the keyword arguments. Okay, that is another thing. Now positional arguments cannot be behind keyword arguments. That was the third concept, right? And the these were the three important concepts. Now before we move on, let's here let's see one more important concept. Okay, so one more concept is about the args, which precedes with a single asterisk, and quarks, which precedes with two asterisks. Now these are arguments, short for arguments, and this is short for keyword arguments. So these are flexible. Now we'll just try to understand that what is the significance of single asterisks and double asterisks and why they are different and all. Okay, but essentially, like sometime you might wish to write a function in which you don't initially know that how many arguments you are passing, like print function, if you recall. That is a system build function, but it can accept any number of arguments. So if you're writing a function, whether you do not know how many inputs I am going to get or how many arguments I am going to get, you can use these type of tweaks. Okay. In this case, you can use the special form like a star args or a star quars to catch all elements or all arguments that are passed. So as everything, like let's go ahead and see an example. So I'm writing an example over here. So I'm defining a function catch all and I'm passing it args and okay, and I'm printing over here. I'm printing what is being passed, right? Okay, let me print. Okay, and args. And what I'm doing is I'm printing the type of it also. What type of argument is passed, okay? Now the same thing I will do for my keyword arguments. And I'm going to print the type of that also. Clear? Simple. Okay, and I'll run that. Now I'll call this function. So this function is not doing anything. It's just printing what it is getting as an argument. The only special thing about this is these arguments are something different, right, than how we are passing the positional and keyword and default arguments, right? This is with asterisks and all. So we'll see that what it is, okay? Now let me call that function catch all, which I have defined, and I will pass some arguments over here, and I will also pass a5 b is equal to 6. Okay, now if you notice, friends, over here what I'm passing is I'm passing positional arguments and I'm passing keyword arguments, right? So the way it works is my keyword arguments will go into the KW args, right, quarks, or the thing which starts with asterisk, and my positional argument all will go over here in the star arguments, right? So the first will be a sequence type, like list or tuple type um, uh, data. The second will become a dict type, right? Because this is A and 5, B goes to 6, right? So let's see and run it. Okay. So if you see, now this is taking that args, star args, okay, and what it is getting 1 2 3 4, and it is storing into a class which is tuple. See the print type, I'm printing it, so it is storing it into a tuple class. Okay, so my args, where it is being received at the function end, these arguments, is storing it inside a tuple. My keyword arguments is stored in a dict type. If you notice, my A5, B6, it is getting stored in a dict type, right? So that's what it is, right? Now these keywords, if you see over here, right? These are like, there is no special significance to these names, args and quarks. It's just a normal convention to call these arguments and keyword arguments. Even if I have to, let's say I remove this, I will show you. Okay. So arg and keyword are okay. I will remove over here and let me just change it to show you that these keywords hold no special significance apart from nomenclature perspective, right? This is a tradition or custom. Okay, so if I run it again, see, I defined my first argument, which is of a tuple type. The second is a dict type, right? That's all this star and double star means, right? And when it is getting printed or or the type of that is getting printed, it is printed as tuple and dict. The first are the positional ones, which goes into tuple. The later are the keyword ones, are with starting with double asterisk, and it goes into the dict type. Okay, so this is mainly used that if sometime we are writing a function, we do not know how many positional or keyword arguments we are getting to pass. This is the easy way to write a function, right? And we can accept all the arguments from the user. Okay, clear? That is the use. That is the use of it. Okay. Now, as I said that here the names of the args and cogs are not important, but the asterisk and the double asterisk which matters, right? Okay, these args and cogs, as I was saying, doesn't hold any special significance, right? The name doesn't. It's a traditionally we call these arguments and keyword arguments. What is important is this: the how the context of a star, single star and double star matters, right? So single star gets expanded into a sequence type object like a tuple, and the double star gets expanded into a dict type object, right? Which we can see from our example. Okay. Now, this difference of the star and single and double star, right, can be used in other places also. By other places, I mean that when you are not just defining the function, but when you are calling the functions also, you can make use of it. Okay, so this is a way in which you can pass a set of positional arguments or a set of keyword arguments. So let's see with an example. So we have already defined a function, and okay, let's define a tuple first and a list, dict, sorry. So my tuple will be, let's see, I will do 5, 6, 7. Okay, and my keyword dict type will be, let's say, pi colon 3.14 comma, yeah, let's just pass one element. Okay, and now I'm calling it catch all, catch underscore all. So friends, again, the first time we used it is for the definition. Now we are going to use it for calling that function. Okay, so what we'll do is all star input asterisk inputs, and we are going to call my dict type keywords also, and I'm passing those arguments. Okay, now let's see what happens. What will happen is, friends, over here is that this input asterisk, it will understand that this is a sequence type object. It will get over there in this, and it will get unpacked. So 5, 6, 7 will come, and this dict type object, it will know, Python will know that this is a dict type object because it is preceding with 2 stars, and it will go over there and get unpacked as a dictionary. Okay, there is some problem. Okay, keyword and keywords. Yes, I have to remove. Okay, now you can see, right? I ran the same function. Now when I call the function also, I am passing the single and the double star or the double asterisk, right? And it is again taking this 5, 6, 7, the tuple object over here, and this keyword argument pi 3.14, right? So I hope guys this is clear. Again, to summarize, this single and double star only, or asterisk, only mean the way that what kind of sequence object is coming or getting passed. Why it is used? It is used for defining functions where you do not know beforehand how many positional and keyword arguments are going to be passed. For positional arguments, you pass a tuple. For keyword arguments, you pass a dict type object, right? And the way to do it with a asterisk and double asterisk. Again, at the end, it is not just for defining the function, but for calling the function also, you can use this method, the star and double star. Okay. Now let's move on to the last concept for the day, which is lambda functions. Okay. Lambda. Now as I was saying that we have covered majority of the functions which is predefined with a def keyword. Okay. There is another set of functions. These are like micro functions, small functions, a variant of functions, whatever you want to call it. It is anonymous in nature. So sometimes we have to write some piece of code, but we do not want to formally define a function. Okay, it probably it's a reusable piece of code, but it's only a single line or something. What we do is we use that with lambda. Okay, let's see it with an example. Let me see that I'm defining a lambda as, and the lambda is defined not as a def but as a lambda keyword. Okay, x, y. Let me write that and then I will explain that what I meant. Okay. So this is how lambda is defining, just in one straight line. Okay. What you are doing is you are defining a function. Okay. It is taking two inputs, x and y. What it is returning? It is returning x plus y. So it is doing an addition operation of all the parameters which is getting passed, and we are creating it into a function which is z. Now let me do z12. Okay. So z is my lambda function, right? It is taking two input x and y. X and y are passed as 1 and 2. It is doing an add operation. Now let's see what it. Oh, okay. I run this. I didn't run that. Okay. So I didn't run this code cell, so that's why it was undefined. Okay. Now z becomes 3. Okay. Very simple. Now why we are using lambda? Lambda is doing for very small operation like single line. It is essentially single line, right? And we do not want to do elaborate def statement, and we want to make it very compact and micro and call that whenever it is necessary, right? So this is another aspect or another way in which you can define a function using lambda function. Now if we have to expand and write this same thing into a more traditional our def statement, right? So what we'll define z again over here, and we'll pass xy, right? We'll put a colon, and then what we'll do is return x plus y, right? So this thing and this thing are equivalent. This is just getting done in a line. This is done in two lines, right? But you got the picture that it is so small that it doesn't make sense to have a formal definition of. But nonetheless, let's run this and then see z, this time 2, 2, and z becomes 4. So I'm calling z over here. Let's define it as something like z1 or something, right? Just to ensure that we are calling this, okay, the newly. Okay, let me run this, and z1 again same defined as z, and it is adding two numbers, right? So this particular code and this particular code is exactly the same, right? It is just a easier, shorter way of defining a function. Okay. Okay, friends, this brings us to the end of today's session. If you like these type of content, please do like, subscribe, and share it with your friends. You can, if you have any open question, you can feel free to comment it, and I will try to answer it as well. Let's see you all in the next video. Till then, this is ML with AP signing off. Thank you. Bye.